Hello students, welcome to your channel Parivartan Physics. See, we are in the series of videos where we are learning 5-mark important derivations from all the chapters of second PUC. From first chapter and second chapter we have already learned the derivations. So in this video we'll learn the important derivations from current electricity. In another series of videos we are learning 5-mark important numericals from second PUC Physics. So there also first and second chapter has been completed. Third chapter video will be shortly uploaded, right? And I'm going to start one more series of videos which will prepare you for KCET 2026. Soon I will start it, right? Many of you are requesting, soon I will start it, right? Okay, without making any delay, let us begin the video then. See, there are three important 5-mark derivations in this chapter. Those are combination of cells as well as Wheatstone's network. Cells in series and cells in parallel as well as Wheatstone's network. These are the three important derivations which may be asked for 5 marks. So first we'll see about these derivations. Okay, so first derivation is about equivalent EMF and equivalent internal resistance of two cells in series. Two cells in series. Okay, let me say we are having two cells here. Let me say we are having two cells here. This is cell number 1 and this is cell number 2. Correct? So EMF of the first cell is E1, EMF of the second cell is E2. Andre EMF ಬೇರೆ ಬೇರೆ ಅದಾವ. Identical cells ಅಲ್ಲ. Identical cells ಅಂದ್ರೆ EMF same ಇರುವಂತ cells identical cells ಅಂತ ಕರೀತಾರೆ. Okay, internal resistance is R1 of first cell, internal resistance is R2 of second cell. Correct? Okay, let me name the points as ಈ ಪಾಯಿಂಟ್ಸ್ ಗಳನ್ನ ಈ ತರ ನೇಮ್ ಮಾಡ್ಕೊತೀನಿ. This is A, this point is B and this point is C. Since the cells are in series, there will be same current flowing in both the cells. ಎರಡು cells ಒಳಗೆ ನಮಗೆ same current I ಅಂತ flow ಆಗ್ತಿರ್ತದೆ. Because we know very well in series combination current will be same and voltage will be different, right? Okay, so this is the series combination of two cells. I will draw an equivalent circuit of these two cells here. Equivalent circuit means it will be consisting only one cell, and this cell is said to be equivalent to these cells connected in series. Equivalent andre meaning ಏನು? When you connect these two cells in series, how much total EMF and total internal resistance it provide, the same EMF and same internal resistance this will provide. How much current these two cells together will provide, the same current this cell will provide. That's why it is called equivalent. ಅಂದ್ರೆ ಇವು ಎರಡು ಸೀರೀಸ್ ಒಳಗಿದ್ದಾಗ ಎಷ್ಟು ಕೆಲಸ ಮಾಡ್ತಾವ ಅಷ್ಟು ಇದು ಒಂದೇ ಕೆಲಸ ಮಾಡುತ್ತೆ. ಇವೆರಡಕ್ಕೂ ಇದು ಈಕ್ವಲ್ ಅಂದಂಗೆ. That's why it is equivalent cell. EMF of this equivalent cell I will write it as ES, right? Series effective EMF andangri. Amale internal resistance I will write it as RS. I will name these points as A and C. This is A and C, and let the current be same, that is I. E circuit ಒಳಗೆ ಎಷ್ಟು current ಅದ ಅಷ್ಟೇ current ಇಲ್ಲಿ ಕೂಡ ಅದ. Correct? Okay, here I have written everything. E1, E2, R1, R2, I, current, VA, VB, VC, potential differences. Okay, ಈಗ ನೋಡ್ರಿ ಇಲ್ಲಿ ನಮಗೆ ಇನ್ನ ಮೂರು ಟರ್ಮ್ಸ್ ನಾವು ಇಲ್ಲಿ ನೇಮ್ ಮಾಡ್ಕೋಬೇಕು. VA, VB, VC. Okay, now what is VA? VA means it is potential difference. Right? See, potential at point A, potential at point B, potential at point C respectively. Potential difference between A and B. See, this is point A, this is point B. So the potential difference between A and B is written as VAB. This is point B, this is point C. The potential difference between these two is written as VBC, right? VBC. And the potential difference between these 2 points I will write it as VAC. Idina VAC anta barite. Correct? Okay, now let us go on writing. See, potential difference between points A and B. So ಈ ಎರಡು ಪಾಯಿಂಟ್ಸ್ ನೋಡ್ರಿ, ಇಲ್ಲೇ ನಾನು ನಿಮಗೆ ಸ್ಪೆಷಲಿ ಹೇಳ್ತೀನಿ, ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಸೆಲ್ಸ್ ಅದ ಏನು ಎರಡು ಫಾರ್ಮುಲಾ, ಎರಡು ಡೆರಿವೇಷನ್ಸ್, ಇವು ಎರಡು ಡೆರಿವೇಷನ್ಸ್ ಒಂದೇ ಫಾರ್ಮುಲಾ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದಾವ. ಇಫ್ ಯು ನೋ ದಿಸ್ ಫಾರ್ಮುಲಾ, ಇಫ್ ಯು ನೋಟ್ ಹೌ ಟು ಅಪ್ಲೈ ದಿಸ್ ಫಾರ್ಮುಲಾ, ದೆನ್ ಇಟ್ಸ್ ಓವರ್. ನೀವು ಈ ಡೆರಿವೇಷನ್ ಮುಗಿತಂದಂಗ್ರಿ, ರೈಟ್? ದಟ್ ಈಸ್ the formula of terminal potential difference. V is equal to E minus IR. V is equal to E minus IR. This is the single formula which you have to use in this derivation, and if you apply this formula, this derivation is over. Mugitri, right? So E formula now we terminal potential difference formula now ಏನು ಮಾಡಬೇಕಂತಂದ್ರೆ, once we have to apply it for first cell, once we have to apply it for second cell, and once we have to apply it for equivalent cell, and go on simplifying, you will get the answer. Even in parallel combination also we are going to use the same thing, right? So remember, terminal potential difference, V is equal to E minus IR. Okay, here they are asking you to write the, we have to write the potential difference between A and B. Potential difference between A and B means terminal potential difference of this cell. Terminal potential difference of this cell. So I will write that terminal potential difference of the cell as, VAB. That terminal potential difference of the cell as VAB. VAB means it will be equal to E minus IR. Same terminal potential difference formula I am applying for the first cell. Right? First cell like new formula apply madri. Okay. EMF of the first cell is E1. Current is I. Internal resistance is R1. Correct? So I got the terminal potential difference of the first cell, or simply I can say it is the potential difference between A and B. Similarly, potential difference between B and C. See, potential difference between B and C antandre it is terminal potential difference of second cell. It is terminal potential difference of second cell. So second cell ki na formula apply madtini. VBC is equal to, again I will write it as E minus IR. EMF of the second cell is E2. Current is I. Internal resistance is R2. Correct? So we have written terminal potential difference of first cell, terminal potential difference of second cell. Next nodri, potential difference between points A and C. ಈಗ potential difference between points A and C ಅಂತಂದ್ರೆ these 2 points, ಈ ಎರಡು points. So I will write it here. Potential difference between the points AC will be equal to VAB minus VBC ಅಂತನ ಬರೀತೀನಿ. VAB plus VBC I will write. Right? Total potential difference. ಇಲ್ಲೇ ನೋಡ್ರಿ ನಮಗೆ ಇದು potential difference ಬೇಕಾಗಿದೆ. So in this there are two potential differences. One is VAB, another one is VBC. So we have to add these both to get the total potential difference. You already know the values of VAB and VBC. You already ನಿಮಗೆ ಗೊತ್ತದವ್ರಿ. Correct? So ಈಗ ಅದನ್ನ ನಾ ಬರೀತೀನಿ ಇಲ್ಲ. Here I will write. Okay, let me write it here. See, VAC is equal to VAB. What is the value of VAB? It is E1 minus IR1 plus VBC. What is the value of VBC? E2 minus IR2. Okay, it is E2 minus IR2. Correct? Okay, next what I will do is I will take EMFs on one side, EMFs first. That means I will write E1 plus E2 first. Minus IR1 minus IR2, I will take minus I common. In the bracket I will get R1 plus R2. Correct? ಇಲ್ಲಿ ಎರಡು term ಅದಾವ, minus IR1 minus IR2. Okay, so let this be equation number 1. Okay, let this be equation number 1. Okay, I will call it as equation number 1. Next, for equivalent cell, here I will write for equivalent cell. Terminal potential difference of that cell, I will write it as VAC. Terminal potential difference of the cell. Right? ಅಂದ್ರೆ ಈಗ ಹೆಂಗೆ ನೀವು V is equal to E minus IR ಒಮ್ಮೆ ಈ ಸೆಲ್ ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರಿ, ಒಮ್ಮೆ ಈ ಸೆಲ್ ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರಿ, ಆಮೇಲೆ ಇವೆರಡು ಆಡ್ ಮಾಡ್ಕೊಂಡು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರಿ, ಆ ತರ apply this formula for this cell, E minus IR. Okay, so I will write it as E minus IR. What is E here? E means it is ES. What is I? It is I. What is R? R means it is RS. Correct? So this is terminal potential difference of the equivalent cell. I will write it as equation 2. Okay. Well, see already if for equivalent cell, this equivalent cell E antandre equivalent EMF is actually ES, right? This is actually ES and this is actually RS. Okay. See, comparing both the cells, both the equations, comparing equations 1 and 2. I will compare these both equations, comparing equations 1 and 2. Equation 1 ಒಳಗೆ ನೋಡ್ರಿ LHS is same, VAC. Here also LHS is same, VAC. After that, in RHS, first term here we have E1 plus E2, here we have ES. And then we have minus I, Here we have R1 plus R2, here we have RS. So, in the place of ES we have E1 plus E2. In the place of RS we have R1 plus R2. Therefore, I can write ES is equal to E1 plus E2. And RS is equal to R1 plus R2. RS is equal to R1 plus R2. So this is effective EMF and effective internal resistance when two cells are connected in series. When two cells are connected in series, this is effective EMF and this is effective internal resistance. Next, for n cells, the same equation will be like this. ES is equal to E1 plus E2 plus so on En, correct? And RS is equal to R1 plus R2 plus so on Rn, right? This is for n cells connected in series, correct? So that is all about how to derive an equation of effective equivalent EMF when two cells are connected in series and equivalent internal resistance when two cells are connected in series. Hope you have understood the derivation. Okay. Next, we'll go for the second derivation, that is equivalent EMF and internal resistance of two cells connected in parallel. Okay, we'll go for the parallel combination now. See, here we'll take the parallel combination of two cells. Parallel combination of two cells. This is the first cell. This is the first cell. And here I will take one more cell. Correct? See, parallel means positive and positive, negative and negative. You have to connect positive, positive, negative, negative. And it has to be like this. Correct? Okay. Let the EMF of the first cell be taken as E1. EMF of the first cell is E1 and internal resistance is R1. EMF of the second cell is E2 and internal resistance is R2. Current coming out from first cell is taken as I1 and current coming out from second cell is taken as I2. These two currents will add and they will flow here as I. If you do currents namaga add agi ee branch olaga I1 plus I2 is equal to I ante ee kada flow agtade. Correct? So this is the parallel combination of two cells. I will draw the equivalent circuit of this. Equivalent andre nodri alli onde cell irbeku. ಇದಕ್ಕೆ ಯಾಕೆ equivalent ಅಂತೀವಿ? ಯಾಕಂತಂದ್ರೆ this cell does the work what these two cells in parallel can do. ಇವೆರಡು ಪ್ಯಾರಲಲ್ ಒಳಗೆ ಇದ್ದಾಗ ಏನು ಮಾಡಬಹುದು, ಅದು ಇದು ಒಂದೇ ಸೆಲ್ ಅಷ್ಟು ಕೆಲಸ ಮಾಡ್ತದೆ. How much current together these two cells can provide, the same current this cell can provide, right? That's why it is called equivalent. Okay, here the current is I. ಎರಡು cells ಕೂಡಿ ನಮಗೆ current ಎಷ್ಟು ಬಂತ್ರಿ? I ಅಂತ ಬಂತು. The same current this cell will provide, I. Let the EMF of this cell be taken as EP and internal resistance of this cell be taken as RS. Correct? That is equivalent cell. Okay, E1, E2, EMF of two cells connected in parallel. R1, R2, internal resistance of two cells. I1, current from first cell E1. I2, current from second cell E2. Next, I, total current, that is equal to I1 plus I2. Next, V, VAB is equal to VA minus VC. AB ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಪಾಯಿಂಟ್ಸ್ ಇರ್ತಾವ ನಮಗೆ. This is A and this is B. Correct? Okay, listen. Terminal potential difference across the cell E1. I have told you in the previous derivation only. In both the derivations, we are going to use the single formula, that is terminal potential difference formula. And it is given as V is equal to E minus IR. The same formula you have to apply for all three cells. Once you apply it for this, once you apply it for this, once you apply it for this. Correct? Okay. So let me say, we are writing the terminal potential difference of the first cell. See, terminal potential difference of the first cell. I will write it as V. ಯಾಕಂದ್ರೆ ನೋಡ್ರಿ, ಎರಡು ಸೆಲ್ಸ್ ಪ್ಯಾರಲಲ್ ಅದಾವ. ಎರಡು ಸೆಲ್ಸ್ ಪ್ಯಾರಲಲ್ ಒಳಗಿದ್ರೆ ನೋಡ್ರಿ, potential difference between A and B. This cell is also connected between A and B. This cell is also connected between A and B. So ಇಲ್ಲೇ ನೀವು VAB, VBC ತಗೋಬೇಕಂತ ಏನಿಲ್ಲ. ಯಾಕಂದ್ರೆ ಎರಡು ಸೆಲ್ಸ್ ನಮಗೆ A ಮತ್ತು B ನಡುವೆ ಕನೆಕ್ಟ್ ಅದಾವ. ಕರೆಕ್ಟ್? So V is equal to E minus IR is the formula. E minus IR is the formula. Correct? So ಈಗ ಫಸ್ಟ್ ಸೆಲ್ ಗೆ ನಾವು ಬರೀತಿರೋದ್ರಿಂದ EMF of the first cell is E1. Current from the first cell is I1. Internal resistance of the first cell is R1. Like this we will get it. Correct? Okay. Next, from this equation, you get an equation of I1. Okay. ಇದರಿಂದ ನೀವು I1 the equation calculate ಮಾಡ್ಕೊಳ್ಳಿ. How to get it? See, I will write it like this now. ಅದನ್ನ ಈ ತರ ಬರೀತೀನಿ. I will shift I1 R1 to the LHS. I will shift I1 R1 to the LHS, V to the RHS. ಇದು ನಮಗೆ ಏನಾಗ್ತದ್ರಿ? I1 into R1 is equal to E1 minus V ಅಂತ ಬರ್ತದೆ. Okay, ಇದನ್ನ I1 is equal to ಬರ್ಕೊಂಡ್ರೆ, if I write it for I1, ಇದು R1 ನಮಗೆ ಈ ಕಡೆ ಡಿನಾಮಿನೇಟರ್ ಬರ್ತದ್ರಿ. So I will get it as E1 divided by R1 minus V divided by R1. Whole divided by R1 na ಬರ್ತದ್ರಿ, ಅದನ್ನ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ, ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. Correct? So what I got equation of I1. I got equation of I1. Similarly, terminal potential difference across E2. Second cell ke terminal potential difference baridi. So second cell the terminal potential difference V is equal to E minus IR anta ನಾವು ಬರ್ಕೊಂಡ್ರೆ. Now EMF of the second cell is E2. Current from the second cell is I2. Internal resistance of the second cell is R2. Correct? Next, again equated for I2. ಇಲ್ಲಿ ಹೆಂಗೆ ನಿಮಗೆ I1 is equal to equation ಬಂತೆ, ಹಂಗೆ ಇದ್ರೊಳಗೆ ನಿಮ್ಗೆ I2 is equal to equation ಬರಬೇಕು. ಆ ಥರ ಬರ್ಕೊಡ್ರಿ. Okay, shift this I2 into R2 to the LHS. I will get it as I2 into R2 is equal to E2 minus V. ಇದು V ನಮಗೆ ಈ ಕಡೆ ಬಂದರೆ ಮೈನಸ್ ಆಗ್ತದೆ. Shift R2 to the LHS, RHS. It will go to the denominator. ಅದು ನಿಮಗೆ ಆಗ್ತದ್ರಿ, ಅದು ನಿಮಗೆ ಆಗ್ತದೆ I2 is equal to E2 divided by R2, E2 divided by R2 and V divided by R2 minus V divided by R2. Correct? So you got the equations of I1 as well as I2. You got the equations of I1 as well as I2. Next, total current. See, total current is given by total current andre illadu nodri, this current we want. So total current I is equal to, it is equal to I1 plus I2. I1 plus I2. Substitute the values of I1 and I2 here. I1 ಮತ್ತು I2 the value substitute ಮಾಡ್ರಿ. Okay, I1 value ನಿಮಗೆ ಬಂದದ್ರಿ, it is E1 divided by R1 minus V divided by R1 plus I2 value ನಿಮಗೆ ಬಂದದ್ರಿ, it is E2 divided by R2 minus V divided by R2. Correct? So we have added both the currents here. So I will write it like this now. Total current I is equal to, take EMFs first and then internal resistances. So now first E1 divided by R1 plus E2 divided by R2 anta barkoತೀವಿ. E2 divided by R2. Next nodri, ile minus V by R1, idu minus V by R2 antadu. If I take minus V common in that, in the bracket I will get 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2. Okay, well, ಈಗ ನಮಗೆ I is equal to ಎಷ್ಟು equation ಬಂತು. Next, from equivalent cell, okay, let this be equation number 1. ಈಗ next ನೋಡ್ರಿ, from equivalent cell ಅಂದ್ರೆ ಈ ಸೆಲ್ಗೆ ನೀವು ಏನು ಮಾಡ್ರಿ, ಟರ್ಮಿನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ರಿ, I is equal to ಬರೀರಿ. ರೈಟ್, ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡಿದ್ವಿ, ಟರ್ಮಿನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ I is equal to terminal potential difference I is equal to. Similarly, write the terminal potential difference of this cell. So I will write it as V is equal to E minus IR. E means it is EP, and I means it is I, R means it is RP. Okay, ಈಗ ಇದನ್ನ ಮತ್ತೆ ನೀವು current equal to equate ಮಾಡ್ಕೊಳ್ಳಿ. Equate it for current. So if I equate it for current, see, shift this IRP on that side. So I will get it as IRP is equal to, ಈ ಕಡೆ ನಿಮಗೆ EP ಅದ, EP minus ಇದು V ಈ ಕಡೆ ಬಂದ್ರೆ minus V ಅಂತ ಆಗ್ತದೆ, minus V. Correct? So I is equal to, if I write, I will get it as EP divided by RP minus V divided by RP. Let this be equation number 2. Correct? Since current in first circuit and current in second circuit both are same, LHS of both the equations are same. Correct? Compare equations 1 and 2. In place of EP by RP, here we are having E1 by R1 plus E2 by R2. Okay, E term namgada, E1 by R1 plus E2 by R2. Here we have minus V, here also we have minus V. Here we have 1 by R1 plus 1 by R2, here we have 1 by RP. Correct? So comparing both the equations, what I will get? I will get EP divided by RP is equal to, it will be E1 divided by R1 E1 divided by R1 plus E2 divided by R2. E2 divided by R2. It's ಸ್ವಲ್ಪ simplify ಮಾಡ್ಕೊಳ್ಳೋಣ. Let us simplify this. Okay, ಇದು ಸ್ವಲ್ಪ simplify ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, so I will simplify it like this. ಅಥವಾ ಮೊದಲು internal resistance ಬರೋಣ. Okay, let us write internal resistance. Here we are having 1 by Rp. Here we have 1 by Rp. Minus V 1 by Rp ಇದೆ. ಇಲ್ಲಿ minus V ಇದೆ. 1 by Rp ಜಾಗದಾಗ ನಮಗೆ 1 by R1 plus 1 by R2 ಅಂತದೆ. So it is 1 by R1 plus 1 by R2. Resistance formula ಅಂತೂ ಸೇಮ್ ನೀವು ಕಾಂಬಿನೇಷನ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನು ಫಾರ್ಮುಲಾ ಬರ್ತಾವೆ ಅವೇ ಫಾರ್ಮುಲಾಸ್ ಇರ್ತಾವೆ. Okay, so simplifying this I will get Rp is equal to what I will get R1 into R2 divided by R1 plus R2. ಇದು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ಳೋದ್ರಿಂದರೆ ಅಂದ್ರೆ ನೀವು R2 ಈ ಕಡೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರಿ R1 ಈ ಕಡೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ Rp is equal to ಬರ್ಕೊಂಡ್ರೆ this much I will get Rp. Okay, next now you simplify this. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ರಿ. Okay, ಇಲ್ಲೇ ನಿಮಗೆ EP divided by Rp is equal to ಏನು ಬರ್ತದಪ್ಪ ಅಂತಂದ್ರೆ ಇದು ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ರಿ. ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ದಿಸ್ R2 you multiply for E1, you will get it as E1 into R2, and R1 you multiply for E2, you will get it as E2 into R1. E2 into R1. Right? Cross multiply madadri. R2 into E1, R1 into E2 divided by R1 plus R1 plus R2. R1 plus R2. Okay, next you multiply Rp on this side. What you will get? You will get EP is equal to E1 R2 plus E2 R1 divided by R1 plus R2. You take Rp on this side, it will get multiplied. Ikkade nanga Rp anta multiply agtade. In that place you substitute the value of Rp. Rp value substitute madri. Okay, Rp value na enadru substitute madidre it will be R1 into R2 divided by R1 plus R2. Okay, R1 into R2 divided by R1 plus R2. Okay, so finally I got this much. See here, sorry, one thing I have written wrong here. I'm extremely sorry. See this one, it will not be R1 plus R2. ಇದು ಮತ್ತೊಮ್ಮೆ ಬರೀತೀನಿ. See, cross multiply ಮಾಡ್ಕೋರಿ. E1 into R2 plus E2 into R1 divided by R1 into R2. Right? ಇವೆರಡು multiply ಆಗ್ತಾರೋ denominator. Now you multiply Rp on that side. What you will get? EP is equal to E1 into R2 plus E2 into R1 divided by R1 into R2 into Rp. Substitute the value of Rp here. What you will get? Rp value ನೀವು ಇಲ್ಲಿ substitute ಮಾಡ್ಕೊಂಡ್ರೆ R1 into R2 divided by R1 plus R2 you will get. Correct? Rp value ಇಲ್ಲಿದೆ, ಅದನ್ನ substitute ಮಾಡಿದ್ವಿ. R1 into R2 will get cancelled. So finally EP I will get it as E1 into R2 plus E2 into R1 divided by R1 plus R2. Correct? So this is effective parallel EMF and this is effective internal resistance. Right? When two cells are connected in parallel, this is the effective EMF and this is the effective internal resistance. Hope you understood this derivation. Okay, next. First, ಈಗ ನಾವು Wheatstone's network the derivation ಹೋಗಕ್ಕಿಂತ ಮುಂಚೆ we should understand about Kirchhoff's laws. Kirchhoff's first law ಏನದ, it is also called as Kirchhoff's current law, or it is also called as junction rule, because this is applied for junction. Kirchhoff's second law or Kirchhoff's voltage law, KVL, is also called as loop rule, because it is applied for loop. Okay, well, first Kirchhoff's law ಏನು ಹೇಳ್ತದ್ರಿ, in an electrical network at a node means it is called junction means it is a point where two or more wires are meeting. ಎರಡು ಅಥವಾ ಎರಡಕ್ಕಿಂತ ಜಾಸ್ತಿ ವೈರ್ಗಳು ಎಲ್ಲಿ ಕೂಡ್ತಿರ್ತಾವೆ ಆ ಪಾಯಿಂಟ್ ಗೆ ಜಂಕ್ಷನ್ ಅಥವಾ ನೋಡ್ ಅಂತ ಕರೀತಾರೆ. So at a junction the sum of incoming current is equal to the sum of outgoing current. Right? ಎಷ್ಟು ಕರೆಂಟ್ಸ್ ಇನ್ಕಮಿಂಗ್ ಬರ್ತಿರ್ತಾವ ಅಷ್ಟ ಕರೆಂಟ್ಸ್ ಔಟ್ಗೋಯಿಂಗ್ ಇರ್ತಾವ. ಸಾರಿ ಸಮ್ ಆಫ್ ಇನ್ಕಮಿಂಗ್ ಮತ್ತು ಔಟ್ ಗೋಯಿಂಗ್ ಕರೆಂಟ್ಸ್ ಈಕ್ವಲ್ ಇರ್ತಾವ ಅಂತ ಹೇಳ್ತದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ನಾ ಇಲ್ಲಿ ಒಂದು ಸರ್ಕಿಟ್ ತಗೋತೀನಿ. ಐ ವಿಲ್ ಟೇಕ್ ಅ ಸರ್ಕಿಟ್ ಹಿಯರ್. ಓಕೆ okay, so these many branches are meeting here at this point. So this point is called junction ಅಥವಾ node ಅಂತ ಕರೀತಾರೆ. Correct? So this is R1, R2, R3, R4, R5. Correct? So here this is I1, this is I2, this is I3, this is I4, and this is I5. So here you have to identify the incoming and outgoing currents. Currents which are flowing towards the junction, currents which are flowing towards the junction are called incoming currents. I1 is flowing towards the junction, it is incoming. I2 towards the junction, incoming. I3 away from the junction, outgoing. I4 towards the junction, incoming. I5 away from the junction, outgoing. That's why we can write the equation like this. Nodri, total incoming current is equal to total outgoing current. This is the equation of Kirchhoff's first law. So total incoming current I1 plus I2 plus I4. So this is I1 plus I2 plus I4. This is total incoming current. I1 plus I2 plus I4. Total incoming current. I3 and I5. These are outgoing currents. So this is equal to I3 plus I5. I3 plus I5. This is total incoming current is equal to total outgoing current. Correct? So this is how we have to apply first law. Kirchhoff's first law depends on conservation of charge. Kirchhoff's first law depends on conservation of charge. Okay, that is all about Kirchhoff's first law. We'll go for Kirchhoff's second law. First law is easy. Total incoming current is equal to total outgoing current. ಮುಗಿದೋಯ್ತು first law. Second law ಏನದ ಸ್ವಲ್ಪ ಇದಕ್ಕೆ ರೂಲ್ಸ್ ಬರ್ತಾವ. Let us understand the rules. First statement ನೋಡ್ರಿ, in a loop of an electrical network, the algebraic sum of product of current and resistance is equal to the algebraic sum of EMF. Algebraic sum of current and resistance, product of current and resistance is equal to algebraic sum of EMF. And this law depends on conservation of energy. So the principle of Kirchhoff's second law is conservation of energy. The principle of Kirchhoff's first law is conservation of charge. ಈಗ ನೋಡ್ರಿ, Kirchhoff's law ಬರೀಬೇಕಾದ್ರೆ ಕೆಲವೊಂದಿಷ್ಟು ರೂಲ್ಸ್ ಅದಾವ. ರೂಲ್ಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಫಾಲೋ. ಸೊ ಐ ವಿಲ್ ಟೆಲ್ ಯು ದ ರೂಲ್ಸ್ ಫಸ್ಟ್. First rule is I am telling you the rules to apply KVL. Rules to apply KVL. Kirchhoff's second law. KVL apply ಮಾಡ್ಲಿಕ್ಕೆ ಬೇಕಾದಂತ ರೂಲ್ಸ್ ನೋಡ್ರಿ. ರೂಲ್ಸ್ ನಿಮ್ಗೆ ಬೇರೆ ಬೇರೆ ಬುಕ್ಸ್ ಒಳಗೆ ಬೇರೆ ಬೇರೆ ತರ ಅನ್ನಿಸ್ಬೋದು, ಬಟ್ ಎಲ್ಲ ಆಲ್ ರೂಲ್ಸ್ ವಿಲ್ yield the same result. Only thing is you have to follow any one rule. Don't mix up two different rules. ಈಗ ನಾ ಹೇಳಿದ ಒಂದು ರೂಲು, ಮತ್ತೊಬ್ರು ಹೇಳಿದ ಒಂದು ರೂಲು, ಎರಡು ರೂಲ್ಗಳನ್ನು ಮಿಕ್ಸಪ್ ಮಾಡಬೇಡ್ರಿ. It will give you a sort of confusion and something wrong may go there. So follow any one rule perfectly, right? You will get the correct result only. Okay, ಈಗ according to my rules, see the first rule is we have to consider a direction. ಯಾವ್ದಾದ್ರು ಒಂದು ಡೈರೆಕ್ಷನ್ ತಗೋರಿ, either anti clockwise or clockwise. ಯಾವ್ದಾದ್ರು ಒಂದು ಡೈರೆಕ್ಷನ್ ನೀವು ತಗೊಳ್ರಿ, either anti clockwise or clockwise. Any one direction you have to take. ಲೂಪ್ ಏನ್ ಇರ್ತದಲ್ಲ, ಆ ಲೂಪ್ ಒಳಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಡೈರೆಕ್ಷನ್ ತಗೊಳ್ರಿ. ದಿಸ್ ಇಸ್ ಫಸ್ಟ್ ರೂಲ್. ಸೆಕೆಂಡ್ ರೂಲ್ ಇಸ್ ಈ IR ಪ್ರಾಡಕ್ಟ್ ಬರಿಬೇಕಾದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ದಿಸ್ ಇಸ್ ಅ ಬ್ರಾಂಚ್ in which there is R resistance and I current. ನಾವು ತಗೊಂಡಿರುವಂತ ಡೈರೆಕ್ಷನ್ ಏನದ, ನಾವು ತಗೊಂಡಿರುವಂತ ಡೈರೆಕ್ಷನ್, ಇಫ್ ದ ಡೈರೆಕ್ಷನ್ ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ಈಸ್ ಅಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್ ಇನ್ ದಟ್ ಬ್ರಾಂಚ್, ಆ ಬ್ರಾಂಚ್ ಒಳಗಿಂದ ಕರೆಂಟ್ ದ ಡೈರೆಕ್ಷನ್ ಜೊತೆಗೆ ನಾವು ತಗೊಂಡಿರುವಂತ ಡೈರೆಕ್ಷನ್ ನಾವು ಕಂಪೇರ್ ಮಾಡಬೇಕು. ವಿ ಹ್ಯಾವ್ ಟು ಕಂಪೇರ್. ಕರೆಕ್ಟ್? ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಕಂಪೇರ್ ದೀಸ್ ಬೋತ್. Okay, well, so here since they both are opposite, if they are opposite in direction, that IR product you have to take positive. If the current in the branch is opposite to the direction, you take that IR product as positive. Okay, next, if they are same in direction, if the current in the branch and the direction we have taken both are in same direction, then IR product is taken as negative. ಆ IR ಪ್ರಾಡಕ್ಟ್ ನಾವು ನೆಗೆಟಿವ್ ಅಂತ ತಗೋಬೇಕು. ಕ್ಲಿಯರ್? ಡೈರೆಕ್ಷನ್ಸ್ ಅಪೋಸಿಟ್ ಪ್ಲಸ್ IR, ಡೈರೆಕ್ಷನ್ಸ್ ಸೇಮ್ ಮೈನಸ್ IR. ಲಾಸ್ಟ್ ಥರ್ಡ್ ರೂಲ್. Third rule, EMF ಯಾವಾಗ ಪಾಸಿಟಿವ್ ತಗೋಬೇಕು ಯಾವಾಗ ನೆಗೆಟಿವ್ ತಗೋಬೇಕು. Okay, this is the cell. Here you have to check whether the direction we have taken is passing from negative to positive or positive to negative. Here in this case the direction is passing from negative to positive. Negative on the lower potential, positive on the higher potential. It is moving from lower potential to higher potential. So when it is moving from negative to positive, you take that EMF as plus E. You take that EMF as plus E. Next, if we are passing from positive to negative, if we are passing from positive to negative, you take it as minus E. You take it as minus E. Correct? So these are the three rules you have to follow perfectly to apply Kirchhoff's second law or Kirchhoff's voltage law perfectly. Correct? So for this, let me take an example and let us solve that. Right here, I will take an example. I will take a circuit and let us apply that rule. Okay. So let me say this is the loop. Ille naಮಗೆ R1 ಅಂತಿರಲಿ, this is R1 and this is E1. Correct? Let me say the current in this is I1. So here let me say the current is I2, this is R2, this is R3 and current in this is I3. And here this resistance is R4. Current in this, let me say the current in this is the current in this is I4. EMF of this cell is E2. Correct? This circuit will continue. The circuit is continued here. Okay, now just one loop ತಗೊಂಡಿದೆ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ. ಈಗ ನೋಡ್ರಿ, ಸೊ ದಿಸ್ ಇಸ್ ದ ಲೂಪ್. ಆ ಲೂಪ್ ಹೆಸರನ್ನ ಕೊಡ್ತೀನಿ ABCD ಅಂತ. ABCD. ಈಗ ಈ ಲೂಪಕ್ಕೆ ನಾವು KVL ಅಪ್ಲೈ ಮಾಡಬೇಕು. ವಿ ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ದಿಸ್ KVL. ಫಸ್ಟ್ ರೂಲ್, ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಅ ಡೈರೆಕ್ಷನ್. ಎನಿ ರೂಲ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್, ಎನಿ ಡೈರೆಕ್ಷನ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್, ಐದರ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಆರ್ ಕ್ಲಾಕ್ ವೈಸ್, ಯಾವ್ದು ಬೇಕಾದ ಡೈರೆಕ್ಷನ್ ನಿಮ್ಗೆ ಬೇಕಾದ ತಗೊಳ್ರಿ. Okay, I will take anti-clockwise direction here. Okay, anti-clockwise direction na ತಗೋತೀನಿ. After taking anti-clockwise direction, first you write all IR products. IR products ಬರಿಬೇಕಾದ್ರೆ ನೆನಪಿರಲಿ, direction opposite plus IR, direction same minus IR. Okay, go on writing from this branch. ಈ ಬ್ರಾಂಚ್ ಒಳಗೆ ಬರ್ಕೊಂತ ಹೋಗ್ರಿ. ಇಲ್ಲಿ ಈ ಬ್ರಾಂಚ್ ಒಳಗೆ ನಮ್ಮ ಕರೆಂಟ್ I1 ಅದ, ರೆಸಿಸ್ಟೆನ್ಸ್ R1 ಅದ. The direction we have taken is like this. ನಾವು ತಗೊಂಡಿರೋ ಡೈರೆಕ್ಷನ್ ಈ ತರ ಪಾಸ್ ಆಗತ್ತೆ. ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಅಂಡ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ದೇ ಆರ್ ಸೇಮ್. ದೇ ಆರ್ ಸೇಮ್. ಇಫ್ ದೇ ಆರ್ ಸೇಮ್, ಸೈನ್ ಇಸ್ ಮೈನಸ್. ಕರೆಂಟ್ ಇಸ್ I1, ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ R1. ಫಸ್ಟ್ ಎಲ್ಲ ಐಆರ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಬರ್ದ್ಬಿಡ್ರಿ. ಕರೆಕ್ಟ್? ಸೊ ಈ ಬ್ರಾಂಚ್ ಮುಗೀತು. ದಿಸ್ ಬ್ರಾಂಚ್ ಇಸ್ ಓವರ್. ಕಮ್ ಟು ದಿಸ್ ಬ್ರಾಂಚ್. ಈ ಬ್ರಾಂಚ್ಗೆ ಬರ್ರಿ. ಓಕೆ, ಇಲ್ಲಿ ನೋಡ್ರಿ, ನಾವು ತಗೊಂಡಿರೋಂಥ ಡೈರೆಕ್ಷನ್ ಆಮೇಲೆ ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್, these both are opposite. If they are opposite, then the sign has to be plus. Current into resistance. So I2 is the current, R2 is the resistance. Correct? Okay, now come to this branch. Ee branch ik barri. The direction of the current and the direction we have taken both are opposite. If they are opposite, take it positive. Current is I3, resistance is R3. Correct? So I3 into R3. Now come to the last branch. In the last branch, the direction we have taken and the current in that branch both are same. Directions are same. If the directions are same, sign is negative. Correct? How much is the current? I4. How much is the resistance? R4. So this is I4 into R4. Correct? Okay, you have written all the IR products now. 4 branch adava, 4 branch ಒಳಗಿನ IR products in ಬರುತ್ತೆ. Now go for EMF. EMF ನೋಡ್ರಿ, first cell, the direction we have taken is passing from negative to positive. Right? ನಾವು ತಗೊಂಡಿರೋಂಥ ಡೈರೆಕ್ಷನ್ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಟು ಪಾಸಿಟಿವ್ ಹೊಂಟದ್ರಿ. ಸೊ ಇಫ್ ಇಟ್ ಇಸ್ ಮೂವಿಂಗ್ ಟು ಪಾಸಿಟಿವ್, ಇಟ್ ಇಸ್ ಪ್ಲಸ್ E1. Next, here also we have taken the direction is from negative to positive. ಇಲ್ಲೂ ಕೂಡ ನಮಗೆ ನೆಗೆಟಿವ್ ಟು ಪಾಸಿಟಿವ್ ಹೊಂಟದ್ರಿ. The direction we have taken. ಇಲ್ಲಿ ಕರೆಂಟ್ ನೋಡ್ಬೇಡ್ರಿ. Don't take current. Understand in which direction it is going. ನಾವು ತಗೊಂಡಿರೋ ಡೈರೆಕ್ಷನ್ ಯಾವ ಟರ್ಮಿನಲ್ ದಿಂದ ಯಾವ ಟರ್ಮಿನಲ್ ಹೊಂಟದ್ರಿ. It is moving from negative to positive. So again it is plus E2. ಇನ್ ಕೇಸ್ ಇದು ರಿವರ್ಸ್ ಇತ್ತಂತಂದ್ರೆ ನಮಗೆ ಮೈನಸ್ ಇ ಟು ಅಂತ ಬರಿಬೇಕಾಗ್ತದೆ. ಓಕೆ, ಫಸ್ಟ್ ಈ ತರ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ದ ಅಲ್ಜಬ್ರಿಕ್ ಸಮ್ ಆಫ್ ಆಲ್ ಐ ಆರ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಂಡ್ ಇ ಎಮ್ ಎಫ್ಸ್ ಈಕ್ವಲ್ ಟು 0 ಅಂತ ಬರೀರಿ, ಈಕ್ವಲ್ ಟು 0. Now you shift those EMFs on that side. Okay, so minus IR1 plus I2 R2 plus I3 R3 plus I3 R3 minus I4 R4 is equal to minus E1 minus E2. Correct? So ಈಗ ನಾ ಹೇಳಿದ ರೂಲ್ಸ್ ನೀವು ಅಪ್ಲೈ ಮಾಡಿ ಇಕ್ವೇಶನ್ ಬರೆಯೋದಾದ್ರೆ like this we have to write. First EMF ಮತ್ತು IR products ಎಲ್ಲ LHS ಒಳಗನ ಬರೀರಿ and then shift EMFs on that side. You will get the correct answer. Correct? This is how we have to apply KVL. Hope you understood. On the knowledge of KCL and KVL, we have to derive the balancing condition of Wheatstone's network, which is one of the important derivation in this chapter. So we'll go for that derivation. Okay, Wheatstone's network. It is application of Kirchhoff's laws and is used to find unknown resistance. ಇದು ಎದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರಪ್ಪ ಅಂದ್ರೆ unknown resistance ಅನ್ನು find ಮಾಡಲಿಕ್ಕೆ. Okay, let me say here we are having four resistances. This is P, this is P, this is Q, this is R, and this is S. Four resistances we have. And this is galvanometer, right? This is galvanometer. Okay, so this is galvanometer. First what you do, you first put the directions of current direction. Current always flows from positive terminal of the cell to the negative terminal of the cell. So positive of the cell to the negative of the cell. So current has to enter here. So current has to pass here. It will enter at this point. E point ಒಳಗೆ enter ಆಗ್ತದೆ. ಆ points ಗಳನ್ನು ನಾವು ಇಲ್ಲಿ ಬರೆಯೋಣಂತೆ. Let us write the points. Okay, this is A, this is B, this is C, and this point is D. Okay, so we are writing the currents now. See, I current after coming to junction A. I current after coming to junction A, it has two paths further. ಅದಕ್ಕೆ ಎರಡು ಹಾದಿ ಇದಾವ್ರಿ ಮುಂದೆ. It has two ways, right? ಎರಡು ದಾರಿ ಅದಾವ ಅದಕ್ಕೆ. So it will get divided in two parts. ಅದು ಎರಡು parts ಆಗಿ ಡಿವೈಡ್ ಆಗ್ತದೆ. Okay, I will call this current as I1 and this current as I2. This current as I2. Okay. I1 after coming to junction B, it has again two paths further. ಅದಕ್ಕೆ ಮತ್ತೆ ಮುಂದೆ ಎರಡು ಹಾದಿ ಇದಾವ್ರಿ. So again it divides in two parts. So current in this branch, I will call it as IG. I will call it as IG. And current in this branch, I will call it as I3. I will call it as I3. Correct? Next, IG will be flowing from B to D. I2 will be flowing from A to D. So IG is incoming to D. I2 is incoming to D. These both will get added and they will flow as I4 here. They will flow as I4 here. Finally, same current I will come back to the negative terminal of the battery, right? This is how you have to put the directions of currents. Here the explanation is given. Wheatstone's network consists of four resistance P, Q, R, and S and galvanometer of resistance G connected across the cell E as shown in the figure. Galvanometer the resistance, right? The G andre, it is the resistance of galvanometer. See, network is electrically balanced by adjusting resistance, and for electrically balanced network IG equal to 0. ಸೊ ಇದು ನಾವು ನೆಟ್ವರ್ಕ್ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಅದ ಅಂತ ಇಟ್ಕೊಂಡೇ ಡೆರಿವೇಶನ್ ಮಾಡಬೇಕು. IG equal to 0 ಅದ ಅಂತ ತಿಳ್ಕೊಂಡೇ ನಾವು ಡೆರಿವೇಶನ್ ಮಾಡಬೇಕು. ಓಕೆ, ವೆಲ್, ಸೊ ನಾವು ಲೆಟ್ ಅಸ್ ಪ್ರೊಸೀಡ್ ವಿತ್ ದ ಡೆರಿವೇಶನ್. ಸಿ, ಫಸ್ಟ್ ವಾಟ್ ವಿ ವಿಲ್ ಡೂ ಇಸ್ ವಿ ವಿಲ್ ಅಪ್ಲೈ KCL Kirchhoff's first law for two junctions B as well as D, right? So I will apply KVL, applying KCL for two junctions. We have to apply for first for junction B. For junction B, what we will get? KCL means total incoming current is equal to total outgoing current. So for junction B, which is incoming, I1 is incoming, outgoing I3 and IG are outgoing. So I will write it as I1 is equal to I3 plus IG. I3 plus IG. Since IG is 0, now already ಬರ್ಕೊಂಡಿದ್ದೀವಿ for balanced network IG has to be 0 ಅಂತ. So ಇದು IG ನಮಗೆ 0 ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ ನಮಗೆ ಬಂತ I1 is equal to I3. I1 is equal to I3. Correct? Next, I will apply KCL for junction KCL for junction D. KCL for junction D. So for junction D, incoming currents are I2 and IG. These two are incoming currents. Outgoing current is I4. Outgoing current is I4. So this will be I2 plus IG is equal to I4. I2 plus IG is equal to I4. Since IG is 0, I will write it as I2 is equal to I4. I2 is equal to I4. These both together, I will write it as equation number 1. These both together, I will write it as equation 1. Correct? Okay. Next, let us now apply KVL for the two loops we have here. Okay, let us apply the KVL. Let us apply the KVL. ಈಗ ನಮಗಿಲ್ಲಿ ಎರಡು ಲೂಪ್ಸ್ ಅದಾವ್ರಿ. We are having two loops here. Remember, first loop is A, B, D, A. This is the first loop. Triangle what you are observing here. In that loop, there are three resistances. P, G, Q. Second loop is B, C, D, B. This is the second loop. ಇದ್ರೊಳಗೆ ನಮಗೆ ಮೂರು ರೆಸಿಸ್ಟೆನ್ಸ್ ಅದಾವ, R, S ಮತ್ತು G ಅಂತ. Correct? So to apply KVL, what we have to do? We have to first mark a direction. First we have to take a direction. Correct? So now I will take the direction. I will take the direction in both the loops. Correct? Now we will apply the KVL and we'll write the equation. Okay, here I will write applying KVL for loop. Applying KVL for loop. First loop A, B, D, A. Right? For this loop I will apply it. A, B, D, A. This loop na KVL apply ಮಾಡಿ. First IR products ಬರೀರಿ. Go for this branch first, AB. So the branch AB, ಇದ್ರೊಳಗೆ current I1 is in this direction, and the direction which we have taken is like this. The direction which we have taken is like this. See, it is like this. Correct? Now ತಗೊಂಡಿರುವಂತ direction ನಮಗೆ ಈ ತರ ಅದ. So the direction which we have taken and the direction of current both are opposite. ಅವು ಎರಡು opposite ಅದಾವ್ರಿ. So opposite ಇದ್ರೆ it is plus current into resistance I1 into P. So plus PI1 ಅಂತ ನಾ ಬರೀತೀನಿ. Plus PI1. Okay, ಈ branch ಮುಗಿತು. Come to this branch. See, in the branch BD, the current IG is flowing downwards. The direction we have taken is upwards. So these both directions are opposite. Opposite is the plus. Resistance is G, current is IG. So G into IG. Correct? Next, third branch, DA. The current in this branch is like this. E direction I2 ada. I2 is in this direction. The direction we have taken is same to the direction of I2. If direction same. If direction is same, take it as minus. Current is I2, resistance is Q. So I will write it as QI2. Is there any cell in this loop? There is no cell in this loop. So idine equal to 0 anta baridi. Equal to 0. Okay, after that, IG is already 0, we know that. So this term becomes 0. So I will get PI1 minus QI2 equal to 0. Shift this QI2 on that side. I will get it as PI1 is equal to QI2. PI1 is equal to QI2. And I can write it as P divided by Q is equal to I2 divided by I1. Correct? So this is by applying KVL for loop ABDA. ABDA loop now KVL apply madidvi. Next, let us apply the KVL for another loop now. Let us apply the KVL for another loop, that is second loop BCDB. Okay, here I will write applying KVL for loop BCDB. ಈ loop na KVL apply ಮಾಡ್ತೀವಿ. So go on applying the KVL now. See, For the first branch BC, direction of current and the direction we have taken, these both are opposite. Opposite idre plus. Opposite idre plus. Current is I3, resistance is R. So it is RI3. RI3. Come to this branch. E branch barre. The direction of current and the direction we have taken both are in same direction. Iveru same direction. If direction is same, we have to take it as minus. Current is I4, resistance is S. So we'll write it as SI4. SI4. Come to this branch BD, the direction we have taken, and the direction of IG both are same. Eradu same adu. Idu downwards ada, illi idu kuda namage downwards ada. Correct? So IG and this direction both are same. So take it minus. So minus GIG. Is there any EMF or cell connected in that loop? No. That's why then equal to 0 anta barite. Correct? So this term will become 0 because IG is already 0. Okay. So I will get it as RI3 minus SI4 is equal to 0. Shift this SI4 on that side. I will get it as RI3 is equal to SI4. SI4. Correct? Then I can write it as R divided by S is equal to I4 divided by I3. I4 divided by I3. From equation 1, from equation 1, we know I4 means it is equal to I2. I4 is equal to I2 and I3 is equal to I1. I3 is equal to I1. Correct? So I can write R by S is equal to I2 divided by I1 anta na baribodu. I4 jagadaga na I2 tagotini, I3 jagadaga na I1 tagotini. Now compare these both. Let this be equation number 2 and let this be equation number 3. From equations 2 and 3, RHS is same, I2 by I1, I2 by I1. So we can equate LHS. Now LHS galan equate madkobodu. That's why I will get P divided by Q is equal to R divided by S. This much we will get. So this is said to be the balancing condition of Wheatstone's network. Hope you have understood the derivations clearly, right? Dear students, thank you so much for watching the video completely. And if you are not subscribed to the channel and if you like the content of this channel, please don't forget to subscribe the channel and share the video, share the channel with your friends. Please speak about the channel, please share the channel or mouth talk about the channel with your friends and refer it to your juniors, to your seniors, to your classmates, and please help in growing this channel, right? Thank you so much for being here and watching the video completely. If you need anything else, please put a comment in the comment box. I will surely make a video on that, right? Thank you so much. ಸ್ವಲ್ಪ videos ಬರ್ಲಿಕ್ಕೆ delay ಆಗತ್ತವ, but now it will not happen. So please keep watching the channel and supporting the channel. Thank you. We'll meet again in the next video. Thank you.